Two Python operations look almost identical, sort and sorted, one letter apart, but one of them quietly destroys your list while the other leaves it perfectly intact. Today we untangle sort, reverse, and sorted, and the none trap that catches nearly every beginner. Start with the list L holding 4 to 7, call L.sort, then print L on the very next line. The list has changed. In memory, it is now 2, 4, 7 in increasing order. Sort did not hand you a copy, and it did not keep your original order. It rearranged that exact list in place. Reverse behaves the same way. Call L.reverse on 4, 2, 7, and every element flips end to end. The last becomes the first, the second to last becomes the second, and so on, giving 7 to 4. Again, the original list is mutated, so the order you started with is gone. Both sort and the reverse change the very list you call them on. Here is the trap. Because sort rearranges the list, it has done its whole job through that side effect. So it returns nothing useful, it returns none. That matters the moment you write L is set to L.sort. Python first runs the right side. It sorts the list, then hands back none. The assignment then binds the name L to none. Your sorted list still sits in memory, but you have thrown away the only name that pointed to it. So never write L is set to L.sort. To sort a list, just call L.sort on a line by itself and let the side effect do the work. The same warning applies to reverse. Often you need to keep the original order, say the order people joined the queue, and also get a sorted view for some other purpose. Sorting in place would destroy that original order. The sorted function solves this. Sorted leaves your list L completely unchanged and returns a brand new list that is the sorted version. Because it returns that new list, you must catch it in a variable. Here we call it L_new. A handy way to keep them straight. Sort is a command. Sort this list, change it. Sorted is a request. Please get me the sorted version of the list. The command mutates the list. The request returns something new and leaves the original alone. Sorted also chooses the natural order for the type, increasing for numbers, alphabetical for strings. Sorting only works when the elements can be compared to one another. For integers, sorted order means increasing. For strings, it means alphabetical. But if you build a list holding, say, an integer and a tuple, and then try to sort it, Python has no idea which one is bigger. Behind the scenes, it uses less than to compare elements, and it cannot decide whether a tuple ranks above or below an integer, so it raises a type error. The rule, for sort to work, the list must contain things that can be ordered, all integers, or all strings. Let's trace a full sequence in memory to see exactly what mutates and what does not. Start with L bound to the list 9603, first L.append 5. Append mutates, so L now points to 96035. Next line, the name A is set to sorted of L. Sorted does not touch L. It builds a brand new list in sorted order 0, 3, 5, 6, 9, and A points to that new list. L in memory is still 96035 untouched. Now the tempting mistake. The name B is set to L.sort. This time sort does mutate L, rearranging it in memory to 0, 3, 5, 6, 9. But sort returns none, so B ends up pointing to none, not to a list. That is exactly the trap from before. Never assign the result of sort. Finally, L.reverse flips the now sorted list end to end, so L becomes 96530. Notice the payoff. Sort followed by reverse leaves L in descending order, biggest to smallest, not the original 9603. Sort and reverse changed L directly, so that starting order is gone for good, while A still holds its own independent sorted copy. Let's put this to work. Write a function that takes a sentence and returns its words in sorted order. Take the parameter sen, split it on a space to get a list of words, then produce the sorted result. One version sorts in place. Split the sentence into the list L, call L.sort to rearrange L, then return L. For the sentence look at this photograph, that returns at look photograph. This alphabetical. The second version is a single line, return sorted of the split sentence. Because sorted builds and returns a new list, you can return it directly. Both give the same answer. Reach for sort when you're happy to mutate your list, and sorted when you want a new sorted list in one expression. 3 operations, 1 crucial split. Sort and reverse are commands. They mutate the list in place and hand back none, so never save their result. Sorted is a request. It leaves your list untouched and returns a fresh sorted copy that you must capture in a variable. And whichever you reach for, the elements have to be comparable, all numbers or all strings. Above all, keep the name and the object it points to firmly apart. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.